Welcome, everyone. Aaron Smith and Nancy Bakeman here with the EBA webinar podcast series. And those of you that didn't get to see GreenHack at last week's summit, it's another chance. We've got Jim and Tara here from GreenHack. And I've said before, I came from the commercial HVAC industry in a past life. And when GreenHack is the Cadillac of the commercial real estate industry. And I think it's really exciting to see them entering with some great new products in the residential space. So we've got a chance today to spend some time with them, learn about some great new products, some great opportunities for pilot testing, and ask some questions of them. So we'll have questions in the Q&A. I'm going to hold those till the end. We think we'll get through in about 30 minutes, and then we'll have a great chance for questions at the end of that. And then, as always, this will be recorded. It'll be on the EBA Academy and on the EBA Better Homes, Better Future podcast series. And with that, I'd love to welcome Tara and Jim from GreenHack.
Thank you, Aaron. Always glad to participate with our friends at EBA. So we really appreciate this opportunity. So thank you. And I'll go ahead and jump into it. Today we're really the topic is 4 essential tips on ventilation solutions to help you meet the latest energy codes. And really as we as Aaron said, GreenHack is a commercial leader in ventilation, but we are moving into the residential side, and a lot of it is because we think that the residential market really needs a different approach and different products, and in some cases more of a commercial approach, more of an engineered approach, and fans that are more specification grade and better performing. So with that being said, we're the learning objectives today is we want to really look at the 2021 IECC ventilation requirements and how you can meet them, and really we're focusing, and that's really a broad topic, and and could be a seminar or a webinar on its own, because there's a lot of different paths to get there. We're really going to be focusing on airflow today, because what we look at is, if you don't get no matter what the design is, if you don't get the airflow right, it really doesn't matter. And then also tying into that the 45L federal tax credit, and and being able to get past the certification for the Energy Star for Homes version 3.1 to qualify there. Also, we want to talk about working with energy raters, and then really finish up kind of with how can you just ensure that your installed ventilation system is gonna meet code. So the problem that we're seeing is, and we're working with a lot of builders and a lot of raters out there, and contractors, that we're finding that most home builders are really struggling to meet the stringent ventilation requirements that are found in the latest energy codes without exceeding their budget. So it's a big problem. It's something that I think is I've been in the industry for a long time. I think it's been there, but we didn't really realize it because the fans really weren't being tested. This was interesting. At the last EBA summit in conference last year, the DOE presented findings from a study that they did, and it was a nationwide study on ventilation systems in new homes, and they found that 52% of the ventilation systems they evaluated really failed to produce any meaningful airflow, which is really scary, and that and 67% didn't come close to meeting code. And so that was kind of shocking, and in the room there were a lot of people looking at each other like, how could that be? Because they were looking at really homes that were considered high performance homes that were using high performance ventilation. So like I said, it wasn't an isolated case. This study was nationwide, and when they were looking at comparing the airflow measurements they got compared to the minimum requirements of ASHRAE 62.2, and really kind of had 4 different studies, one in Oregon, one in Colorado, one in Illinois, and then one that covered Florida, Georgia, and South Carolina. I mean, they found this is where they found that, like I said, that 67% over across the board, did not come close to meeting code. And then I guess the question is, why is that? And we really feel that a main contributing factor is that a lot of the residential grade ventilation fans were not designed to move air in real world applications. A lot of the fans were designed to meet the Energy Star standard, which is indicating that a common installation is a 1/4 inch of static, which is interesting. And Stephen Winters Associates, that a lot of people in the EBA world are familiar with, did a pretty intensive research project, evaluating fans and also evaluating installations. And these were Energy Star rated fans. These were not, cheap commodity fans that they tested. But the interesting thing is, when they were trying to determine what is, really appropriate as far as static pressure, your resistance to flow in a common or real world application, they really were recommending that it would really, we should look at providing information at 0.4 inch static pressure. That, throw out the 0.1 that's still out there that they said was pretty meaningless, and that use the 1/4 inch as a minimum, but really focus in on providing tested and certified data to builders and contractors at 0.4 inch. And it was interesting, if you look at their study they did on installations, they found that if you just had 16 feet of straight loose flex duct, 4-inch flex, with no termination, that was that they were seeing 0.4 inch static. And there's been other studies out there. A lot of people know Joe Nagin, who's been in the industry a long time, very well respected up here in Wisconsin. And he's done studies where he's seen that 6.5 feet of 4-inch flex and a slight elbow and a termination, whether it be a wall cap or roof cap, is going to get your installation is going to be at 0.4 inch or above. In fact, Joe was finding that a lot of the wall caps and roof caps, the terminations alone were adding the 1/4 inch of static. So it's interesting. And then if you see the testing that Stephen Winters did and the performance curves here in the middle of the slide, these were 80 CFM Energy Star fans. These were the best fans on the market. You can see, when you go down and you look at you come across at 1/4 inch, you can see like this SS05, this red performance curve at at 0.4 inch, it's zero CFMs. And that's what a lot of people don't realize, is that, you hear a lot of people say, well, I'm just going to buy a 110 CFM and I'll surely get 50. But if you look at these performance curves, you start seeing that at a certain static pressure, the fans cannot maintain airflow anymore, and you're not getting any airflow. And that's where you see back where with the DOE study that you had the 52% that were basically moving no air at all. It's because in a lot of cases the fans, the installation was higher than the static pressure that it was designed to overcome, and they just couldn't maintain airflow. So there's a white paper that Stephen Winters went through, and it's available online, and it's something that we can provide to you too. But I think this is something that the industry is kind of known out there. But I think now that the fans are being tested, and the new codes are requiring it, then it's really becoming prevalent. And I think the other thing you're starting to see with the 45L tax credit now, it's a scenario that that in with the 2021 IECC, that builders are having to really, certify to the states that they're meeting these requirements, or certifying to the government to get their tax credit that they met these specifications. And now there's concerns that there could be audited. And you said that this whole subdivision was tested and certified, and then you're subject to having the government come in and actually double check that. So, this is what I was kind of referring to, is that, this was new in 2021 IECC. This comes right out of section R403.6.3, but requires testing to confirm that the mechanical ventilation system provides the minimum ventilation flow. as referenced by the IRC or the IMC, which is really ASHRAE, they're referencing ASHRAE 62.2, and this includes bath, fans, kitchens, and whole house ventilation. So I've talked to people recently, and they're saying, why is this becoming an issue? Why, it's because fans are being tested now, and people are actually finding out, the actual airflow of some of these installations. And then the Energy Star for homes is very similar. This comes right out of their HVAC design report, that needs to be filled out. That the designer is going to verify airflow. They're gonna check off that it met the requirements of ASHRAE 62.2, 2010 or 2013. The airflow required was, for a continuous system was this CFMs. You got to fill that out, and if you're doing more of a duty cycle, air cycler type installation, what was the airflow, what was the run, time per cycle, and what was the number of minutes for the cycle. So it's, like I said, it's been out there for a while, but in a lot of cases, people were not testing and certifying the fan, or not verifying airflow in the field, and now it's here. So what's the solution? We really think that this is kind of tied back to what, to who EBA is. And I was on the board with EBA for about 5 years, and what we always talked about is that some of these problems that we're facing out there, especially like cost-effective code compliance, it's going to get solved if you've got builders working with manufacturers and contractors and raters, all of us working together to come up with a solution. So what we're doing right now is, we've talked about it, and at the EBA conference last week, we talked about a pilot program, but we're working with the top builders, contractors, and raters in the country and the industry, to develop a unique program that would make it, easier and more cost effective to meet these stringent ventilation requirements found in the latest codes. So, that's the solution that we see is this unique program, this partnership program, and that's where we've been working with. We're not going to say we have it all figured out. We're still learning, but together with, like I said, these top builders and raters, we're learning together on what makes the most sense. So that's where these tips come in, is the things that we have learned so far in this pilot program, is that you got to get the home energy rater involved. They're really key in this, and that's something that we've learned, and it really makes a lot of sense to get them involved for the very beginning. I mean, they can review when they're looking at trying to meet these codes, review the different plans. They can work with Ecotrope and other, the software manufacturers to get the data. The raters have access to that. They can look at, what has been going on in your homes, what makes the most sense. Obviously, they can do the building envelope and duct testing. They can also get in there, and which is important in the pre-drywall inspections, and you look at the insulation, the ducts, the duct installation, the ceiling. And at the end of the day, they're the ones that are going to verify the compliance of IECC or the Energy Star for Homes program. So, what we've realized is, like I said, it's like step number one. Builders really need to work very closely with their raters, and I'll give you an example of how all this kind of went together with a project with Thrive Homes at the end of the presentation. So essential tip number two, take advantage of the manufacturers, work with the manufacturers. Manufacturers can work directly with you to help with design. At GreenEck, we have computer-aided design software that we can work directly with you. And I know, other manufacturers have things like, tools like this too, but where we can figure out exactly, what your installation is, what airflow that you're trying to hit, what is the length of the duct run, what type of duct are you using, how many 90s, how many terminations. And we can use this, we call it ECAPS. We can use this design software to generate a report like what I'm showing here, where and pick out one of our fans that would work. But the information you get is, exactly what your static pressure is. In this case, where we laid it out that it was around 34 feet of flex duct, and a couple of 90s and a termination, and you were looking at a half inch of static, and they wanted 80 CFMs in this project. And using this analysis, we could tell them that at a half inch of static, this fan will still deliver 80 CFMs. So you really kind of know pre-installation what your airflow is going to be, in your system before it's even installed, and long before it's going to be inspected. So there's really no surprises. We can even also, the other thing, we can tell you, what the zones level, are, because with AMCA, and you can see the AMCA rating down there, which is more the commercial, third-party certification body. We are required to test and certify our fans' performance, air and sound, at every point of the performance curve. So if we can calculate what your performance curve is, what your static pressure is, we can tell you exactly what your performance should be, which is very, very helpful when you're doing design. The other thing is, you can take advantage of manufacturer support when it comes to installation. What we're really finding in this pilot program is that, how and where the ventilation system is installed is very important, since a lot of the homes were not designed, especially for an ERV, they weren't designed, to install an ERV. So where do you put it? Is there a mechanical closet? Is there a laundry room? Where do you put it? Where do you duct it out? Is it a dedicated system? Is it a simplified system? There's a lot to discuss there. And so use your manufacturer, to do to not, to help with the installation. And in this case, we have engineers on site helping install a one of our ERVs that's unique because it's ceiling mount, and it's one of the smallest ERVs in the market, which was ideal in this small mechanical closet in a townhouse that was never designed, to include an ERV into that scenario. The other thing is to take a hard look at, not all your ERVs are equal. When you get into these situations, the size of the ERVs are very important too. And they're, some of the ERVs out there are very compact, and they can be up to 66% smaller than a comparable model. And that makes a big difference. So what we've seen too is the installation, not just getting the airflow right, but then, where are we going to put it? How are we going to install it? How are we going to duct it out? How is it, what's the most energy efficient way of doing this? So that's really important also. Essential tip number 3 is you insist on installing, code compliant verified ventilation solutions. And that gets back to some of the things I was talking about, with the AMCA, certification. And even HVI, there's fans, and the HVI certifies, up to, I know fans that are being certified up to 0.625 static, but so what you're getting. But a lot of fans on the market, and have EC motors, with adaptive technology, but there's only a few of them that have been tested and certified to perform in real world applications. That gets back to Stephen Winter and Associates recommendation of providing, 0.4 and above. So you need to be looking for products that have been tested and certified, and they meet that requirement of 0.4 and above. So that they're going to perform and deliver the airflow you need in a real world application. There's also ERVs on the market that not only have the EC motor with the adaptive technology, and you hear discussions about self-balancing or auto-balancing using that adaptive technology, but there's actually ERVs on the market that actually can provide field diagnostics that actually measure real airflow, actual airflow, have the capability of measuring the airflow in the duct collars to see what the maximum capacity is of the installation, what is the maximum, intake, what's the maximum exhaust, and then be able to dial in the precise airflow to meet, the design requirement, but also code and balancing requirements. So once again, these are scenarios where it's you're basically are verifying your installations pre-inspection. There's no surprises. What you have going into it, And in fact, it's a scenario that I'm in discussions with some raters about providing the diagnostic tool where they could actually utilize that if they're testing and certifying our ERVs that have that precision balancing capability. So essential tip number 4, get started. Get started building your partnerships today. I think that's the thing that I've learned, in working with a lot of builders, whether they're big or small, is that start putting those partnerships together. Like I said, working with your rater, working with a manufacturer, getting your contractor involved. If everybody's on the same page and everybody is aligned, it makes it a lot easier. If you take really one of those partners out of the equation, it just changes things. So, I guess that, kind of some main takeaways is you don't have to go this alone. There's builders all over the country that are finding out the hard way. There were a lot of builders with that Department of Energy Building America study that found out the hard way that their current ventilation system was not meeting the required, airflow standards. And failing to meet code can really cost you. When you're talking about callbacks, or you have it, to change the installation, tear fans out, delays in closing. It's not good to not meet code, and like I said, find out at the very end that you don't. So really, our message really is it needs to be the builder, the rater, the manufacturer, and the contractor, like I said, all working together. And what we're seeing, with our pilot program is we've got top builders are partnering up with the top raters and manufacturers, to meet code, lower their HERS ratings, qualify for the 45L tax credit, installing code compliant, verified ventilation fans and advanced air ERVs with best in class SRE and best fan efficacy. It's really a great story, and when it comes all together. And one that is a great story is Panorama House project that you'll see a lot being promoted by Professional Builder, and it's just really a unique project that Gene Myers and the Thrive Home teams are doing. But it all started actually at EBA, not this year, but last year, and talking to Gene Myers about, hey, we're using filtered fresh air supply fans, but we'd like to look at ERVs, but we want to see what that would do to our modeling and what it would do to our HERS ratings. And then, we were down in his neck of the woods, and we worked with Justin Erickson with E3 down there, and he just decided he would help out and jump in and volunteered to do some analysis, and was able to find out that if Thrive and Gene would utilize one of the ERVs that we have that has 84 SRE, that it could greatly impact the job in their installations and lower their HERS ratings. And so from that, this system that Gene and Justin and Greenhack worked on together ended up getting specified in this project. Where you're really, they're looking to be the carbon neutral, net zero energy, just a beautiful project out in Breckenridge, and really will be, like a lot of Thrive's projects, will be cutting edge and example for all of us. But this project utilizes that system that was developed, in conjunction with Gene and Justin and us all working together. So it's going to have the Sync 180 ERVs with that 84% SRE, precision sync control. Gene will know exactly, and Thrive will know exactly what their airflow is, and they're balancing it using that precision ventilation. And then it also includes, all of our, code compliant verified ventilation fans. The master spec, can be used for whole house. They're including humidities, plug and play humidity sensors into it, and also incorporated our multi-spec low profile, spot ventilation fans for, for guest baths and powder rooms and such. So this is just a, kind of an example of what we're seeing, by having this partner program and putting this pilot program together. Like I said, we don't have it all figured out, but we're learning, right? And I think the builders are learning and the raters are learning, and together, we're working to really develop a unique program that I think can be game changing, especially when it comes into addressing, code compliance and doing it, cost effectively. So you're really my last slide, and I'll open up, be open to questions. Is that Greenhick is a strong supporter of EBA. I've always been a strong supporter of EBA. We have a unique program, and I mean, who to better to be in a partnership like what I described than having EBA being in the middle of this. And so we have a partnership program with them. Here's the link to it, and you can go on there and find out more about the program that we have with EBA. But also there's there's an opportunity you to contact us or set up a call if you would like to find out more about the pilot program, this program that we're working on, or if you're interested in interviewing to become, a pilot. We don't have a ton of bandwidth, and like I said, right now, this is more about learning and not really selling, but learning. But there are opportunities that we're looking for more pilots, whether they be a builder or a rater, to get involved with this. And then my contact information, if you want to contact me directly, is at the end of the slide. So Aaron, that's all I had. So I'd be open for questions.
Yeah, and everyone, feel free to put some questions in. But I've got a question to kick us off, Jim. How do you think about an ERV handling the bath fan removal, the removal in the bathrooms versus independent bath fans and a separate ERV in the system? Or maybe how should we all think about that? Or is that something you can help us model in a home? What's kind of the sweet spot as you think about that? Is it that, the best net positive home on the planet, like we really want to do it all through the ERV? Tell me your thoughts on that, and then we'll wait for some questions.
That's a really good question to kick it off. I think
I came up with it myself.
Okay, well, good. Personally, from my point of view, and you got to remember, I'm a bath fan guy, right? After over 20 years in this, and then getting into ERVs, I still think it's ideal to have a bath fan in there, and they're not that expensive, but I think it's ideal to have the bath fan in there to really make sure you're taking care of moisture management and humidity control, and you're really know you're effectively doing. And then plus the homeowners are are familiar with having a bath fan, and it's kind of expect a bath fan there. So personally, I still think that it's best, to put a spot ventilation fan, and some of our multi-spec fan is not a really expensive, not an expensive fan, pretty cost effective, but it gets that done. But I will also say that when you're really looking at cost, and we're seeing this more and more, and it's being very prevalent in the Northwest right now, especially in multifamily, that they are moving forward, with a a high performance, efficient ERV, oversized, so running continuously, ducting it out from the bathrooms, because you need 20 CFMs of continuous to meet that requirement, but also giving the opportunity to boost the RV to a higher speed. So, and having a switch. So that's kind of the best of both worlds, right? So the homeowner could go in there, and they did take a shower, they could flip that switch and boost the ERV to the high speed, to effectively do that. So that's not a bad scenario too. But I think, when you're looking at, cost effective, it's something you should look at, is utilizing the ERV. Like I said, I don't know that I would recommend it just trying to get by with the 20 CFMs continuously, but having that boost function, I think is not a bad option either.
And Jim, does your product have that boost function?
Yeah, it does. It does. I mean, it can be, that can be done manually with just a wall switch, or it could be humidity controlled. You could have a humidity sensor, wall mount humidity sensor in there that we provide or we offer, and it could automatically boost it.
Fantastic. Tell us about the thinking on the ERV and outdoor air quality. I mean, you talked about the Northwest. I think even here for you and I in the Midwest this year, we had
Right.
some issues with outdoor air quality. Um, where's the where are you guys moving? Where's the industry moving with outdoor air quality and the ERV?
Well, I think the industry and we are too are moving towards, being able to monitor that outdoor air and make sure that when the outdoor air is worse than the indoor air, you're not bringing it in. And that's, and this is coming to play with, with fires or dust storms and things. But I think it's really kind of, tying into, the need for the ERV to either have that sensing capability or being part of a system that does. So it's something that we're working on to make maybe what we're calling more of a smart ERV, that would understand what's going on the outside and know that at this point we don't want to be bringing that air in. So I think the industry, the industry's moving that direction. I think we have to.
Great. Any other questions from attendees that you want to put in the Q&A? Oh, here we go. All right. Thank you, Kent. I'm going to go to the chat here and pick up Kent's question. Sorry about that. Well, I've got the Jim, can you see? Oh, here we go. Are there any good developments to measure the airflow for fresh air?
Well, the one thing I briefly mentioned in the presentation, I think is a pretty big development. We call it precision balancing or precision sink control, but our ERVs are really the only ones in the market that have the ability to measure that fresh air in the duct collar. So you're getting that actual airflow from an ERV point of view, of that fresh air, and then you can balance it or adjust it any way you can. So that's a pretty big development. Everyone else is really trying to rely on adaptive technology, or you'll hear auto balancing, but that's just the motor. You're doing some calculations trying to determine the static pressure. This is actual measuring actual. So you could do it. You could do it with an ERV today with the models that we have that have the precision balancing capability. The other product out there that we're actually partnered with as part of this partnership is Haven, Haven IAQ,
Yeah.
and they have an indoor air quality monitoring management system that's kind of unique because their indoor air quality monitor is in the duct. It is in the airstream, and you can utilize it because not only does it do VOCs and particulate matter and humidity and temperature, it also does airflow. So I've seen when people are trying, and that's a relatively cost-effective option, and where you end up getting the monitor and get an app where you can see exactly what the airflow is. So that's another option, and that's something that we actually offer today as a way to control our ERV, because you could utilize a Haven system and then with their controller boost our ERV if there was an event that really required more fresh air. So that's another option, something I've seen out there.
Great. Any other questions from attendees? Otherwise, I'll ask another question. You talked a little bit about multifamily solutions. I think we
Yeah.
saw more and more multifamily projects at EBA this year, but just maybe talk a little bit about your multifamily solution or townhome solution that you showed, and how you're seeing that come into play.
That's been really interesting, and we learned a lot there because we're actually doing a lot of multifamily business more than we are our projects, I should say, more than we are single family. But I'd say size is critical. In multifamily, you've got a mechanical closet, and and like I said, quite frankly, some of the ERVs on the market are just too big, just way too big, and there's no way they're even going to fit. So I think you run into size is critical. I think you also, like we talked about, you also see them probably moving more towards the ERV also ventilating the bathroom. So that's something we already talked about. You also see, as far as installation goes, we have a unique compact little ERV that's designed really for a townhouse. It was one that was pictured in that installation, but it's unique because it's ceiling mount. So you can
Mhm.
mount it on the ceiling, hang it from a chain, get it, where you don't have any room in the mechanical, the mechanical closet, you can hang it up there. And then you also see, the ERVs, are generally not installed with a plug because there's code requirements there where, trying to run a plug in a plenum doesn't meet code, so they're more hardwired. And then you see kind of unique where you have these back-to-back apartments and they want what they call mirrored ERVs, where they're basically being mounted. There's just a wall between them, but they're being mounted, and they want them kind of the complete opposite to help with, with just from a sizing point of view and help with installation. So a lot of similarities, but there's a lot of differences that we see in multifamily too. And the interesting thing is we talk about 2021 IEC and we talk about the 45L tax credit. That's still all relevant in the multifamily. On the fan side, it's kind of interesting. You see a lot more wall mount. We have that we call it a multi-spec, so it's ceiling or wall mount, but
Yeah.
it's only 3.5 inches deep, so you can actually put it in a 2x4 stud wall
Right.
and exhaust up, and then that's really popular because if you don't have to penetrate
Yeah.
the fire rated ceiling, you're saving a lot. You're saving a lot of money. You don't have to buy a $50 ceiling radiation
Right.
damper, and they don't want to cut that hole. They don't want to
Oh,
touch that ceiling. So if they can put it in the
amen.
wall, save money. You
Yeah.
see you see that too. A lot more wall mount ventilation
Oh,
than you
yeah.
see in single family.
Yeah, I think you're exactly right that most multifamily has moved to wall mount ventilations
Yeah,
uh, in the bathrooms because
right,
of that plenum penetration issue and the added
right,
cost that it has.
right.
So that's great. Is is the secret sauce, and you don't have to tell us what your secret sauce is, but I'm going to ask, is the secret sauce the EC motor? I mean, I think that's a technology we saw coming to the HVAC industry. It's mandated in a lot of cases. Is it the ability of that electronic modulating system to adapt to the static pressure in the system that's really the secret sauce?
I think it's part of the secret sauce, but everyone in the industry has already gone to EC motors, right?
Mm,
It's
okay.
it's I mean, you have some manufacturers that's all they make. So to me, the secret sauce is kind of a combination of the EC motor, but then designing that motor to be able to handle and overcome the higher static
Higher
pressures.
static.
So,
Yeah.
I've had people say, "Is your motor better than an alternative, manufacturer?" And I say, I was on the other side, right? So I know I was involved in the development and was responsible for the development. A lot of Panasonic's fans. He was there 19 years, but that I can tell you that the motor is not different, but I can tell you also that the motor was not designed. The design criteria when they were being developed was not to try to move air at 0.4 or 0.5 or 0.625.
Mhm.
That's the other thing. Multifamily, it's not uncommon to see half inch. Everybody out there that has EC motors pretty much all designed to meet Energy Star. I mean, that was the design criteria that I gave my team. Got to
Yeah.
hit Energy Star, got to hit a 1/4 inch. But now I think what we're finding out, and HVI is saying the same thing, is that that you really need to be looking at 1/4 inch to 0.4. That 1/4 inch was just too low. So I think EC
Mm.
motors, great, gives you energy efficiency,
Mm.
ability to do speed control, 2-speed, whole house ventilation,
Mm.
great. Our secret sauce is that Greenhick is a commercial ventilation company. We had no choice but to, with AMCA, certified every point of our performance curve, and we knew that in commercial we had to have fans that performed at a half inch up. We have fans that maintain airflow up to 0.8 static.
Mm.
So I think it's the secret sauce is you've got kind of commercial design criteria, being utilized with an EC motor versus what I'll just say is residential grade fans versus specification grade fans. Is to me that's the secret sauce. Now, can the residential grade manufacturers go back and redesign their motors to overcome the higher static? Yes, they can. It just today they just that hasn't been really a concern until people started testing the fans like we talked about
Mhm.
today, and then you were saying that it is kind of a concern now.
Yeah. Maybe last question. And Armando, it's a great comment. And I would encourage you. I mean, it sounds like a pilot type thing with Jim So I would encourage you to reach out to Jim directly on that. I think it's a great idea. But final question, what's the best way for a builder or their team to engage with you and your team on the design engagement part of it and really getting that dialed in?
I think really to start out with, probably the best thing is either contacting myself or Tara, and really we and have a conversation. We call it an interview, but really we want to understand what codes are they trying to hit, what are their design criteria, what is their procurement objectives. We want to know what their problem is and what they're trying to solve. I think once we know that, then we can get to work on determining, along with, like I said, a rater. I think the rater's got to be right there in the beginning of it too, along with what is the most cost effective design to meet code, and then start working on developing it, and looking at making sure that the fans, like I said, we can use our design software and that tested and certified data to make sure we're giving you exactly what you need. And then also looking at, on the ERVs, not only are we giving you the efficiency you need to accomplish what you're after, but we're giving you an ERV that's going to fit. Right? I mean, that one job that we were showing, the contractor was saying it's going to take a half a day to install this, and that was what they were bidding out to our builder. And after we met with them, they said we can install this in 45 minutes. So I think that's the big part of it, is first just understanding, what are you trying to do, what do you need to do, and how can we help you. So I think it just starts with a conversation.
Fantastic. Jim, Tara, Greenhack, thank you so much for being part of the EBA community and being here with us today. And we'll look forward to talking to you again soon.
Thanks, Aaron. Always a pleasure. Appreciate it.
Bye.
Bye bye.